Listen closely. Out there in the cold, the quiet dark between the stars, something's moving. It's a traveler, a drifter, from parts unknown, headed our way. The astronomers, the folks who spend their nights looking up, have given it a name, 3I/Atlas. The I stands for interstellar. It's definitely not from around here. This thing's been sliding through the blackness for who knows how long, a silent rock cutting across the void. Now it's entered our solar system. Its path is bringing it into the neighborhood of Mars. So the big question, is this strange visitor on a collision course with the red planet? The stakes are always high. It's a cosmic game of billiards. The table is billions of miles wide. Have we spotted it in time? So what exactly is this thing we're calling 3I/Atlas? The honest answer is, we're still figuring that out. Think of it as a dirty snowball, or maybe a dusty rock, hurled out of another star's family and sent wandering. It's a relic, a leftover from the creation of some other distant world. It doesn't make its own light. The reason we can see it at all is because it's getting closer to our sun. As the sun's warmth touches it, the ice on its surface begins to boil off into space, a process called sublimation. This releases a cloud of gas dust that surrounds the object, something they call a coma. The sun's light then pushes on that dust and gas, creating a long, faint tail that stretches out behind it, always pointing away from the sun. That tail is the key. It's our best clue to what this thing is made of. By looking at the light that passes through it, scientists can break it down and see the chemical fingerprints of the materials inside. When we first spot something like 3I/Atlas, the picture is fuzzy. All we have are a few dots on a star chart collected over a couple of nights. Trying to draw a definitive path from just 2 or 3 points is like trying to guess the plot of a movie from a single frame. You can make an educated guess, but you're probably going to be wrong. Early on, the range of possible paths is huge. Some of those early projections might show the object passing harmlessly by. Others might show it coming uncomfortably close to a planet, or even showing a direct impact. This is what they call the cone of uncertainty. And at the beginning, that cone is very, very wide. This is why you hear scary headlines sometimes. An early calculation based on limited data gets released, and it looks like there's a chance of a collision. But that's just part of the process. The important work happens in the days and weeks that follow. With each new night of observation, we get another dot. And each new dot helps us narrow that cone of uncertainty. The pull of giants and the whispers of change. Now, you might be thinking, okay, but can't the path change? And the answer is yes, it can, but not in the way you might think. The biggest bully on the playground is the sun. Its gravity is what's bending the path of 3I/Atlas into that long, sweeping curve. But every other planet in the solar system has its own gravity too. As the object gets closer, the pull of planets like Saturn and Jupiter will give it a tiny, almost imperceptible nudge. It's like a soft breeze trying to change the course of a cannonball. The effect is small, but it's there, and the folks doing the calculations have to account for it. These gravitational nudges are predictable. We know where the planets are, and we know how strong their gravity is. The scars of ages and the vigil of today. Make no mistake, Mars has been hit before, plenty of times. If you look at a detailed map of the red planet, you'll see the evidence plain as day. It's covered in craters, the ancient scars left behind by cosmic collisions over billions of years. Some are small, but others are vast basins hundreds of miles across, reminders of a more violent and chaotic time in the solar system's youth. Even today, Mars gets pelted by smaller rocks. Our orbiters have seen fresh, dark splotches appear in the red dust, the telltale signs of a recent impact from occasional meteorites. It happens. The solar system is not a perfectly safe place, but a hit from a large object, something big enough to leave a major scar, is rare. A hit from a fast-moving interstellar object like 3I/Atlas would be rarer still. So why do we keep watching? Why pour all this time and effort into tracking something that we're 99.999% sure is going to miss? It's a global fire drill. We are the planet's lookout. In the long night of space, most threats are shadows. This one is only passing by.